Good morning. This is Dr. Polaiah, working as a professor in our college, Institute of Aeronautical Engineering College. Today, I'm going to be deliver a lecture, a video lecture on linear and non-linear operations, which are going to be used for the development of image processing. So, in respect of image processing, how these linear and non-linear operations are being used, in the sense, let you going to see here, which are you already knows about this digital image fundamentals, especially which we have already towards to develop a digital image processing unit with the help of elements of visual perception, and the second one is image sensing and acquisition, and third one is sampling and quantization, and fourth one is relationship between pixels, and the fifth one is spatial gray level resolutions. And the last but not least, that is very important, the topic which we are going to discuss today now, that is linear and non-linear operations. So these are the 6 which are help us to develop a digital image processing system. So the digital image processing system is completely depends on certain operational process. So the meaning of operation means which is going to be performed towards to fulfill the task of the operation. So what is the linear and a non-linear image? So you have to understand here the word itself, linear or and non-linear. So linear means what we have to understand in aspect of very general way, in the sense a system of the output should follow the input of the system. That is called linear. That everyone knows actually. So that means simply being we are a technocrats, being we are engineering students, so we had to concentrate on the basic principles of the terms. The terms are which are we are using today on towards to know linear and non-linear images. So linear means what I said. Simple definition is any systematical process of the output should be follows the input of the same system. Then we call as a linear. So coming to the point, if it doesn't follow, that means the system output, that means the processing output doesn't follow input of the system or input of the system process, then we call as a linear. You understood? Can I repeat once again? Yes. So we says that linear means any digital image processing system output should follow the input of the same system. If doesn't follow, then we call as a non-linear system. So now we can define right now in aspect of digital image processing, which can be defined. What does it mean linear and non-linear image? We are right now concentrating on image. That means by seeing an image, you are going to be say it is a linear image. You are going to be say it is a non-linear image. How can we say? So that means we simply going to be define such thing, a linear data that your camera records will look every dark and low in contrast as a raw data. That is linear data. Whereas if you go to a non-linear image, means a non-linear curve needs to be applied to it to make it look like a normal image that you expect to see. That means you are supposed to be understand where that kind of linear and non-linear image is here. You're going to say that if you shoot one of the format of the image, which we may say JPEG images. What do you mean JPEG? This is one of the format which we are using for your image processing. So such a formatted images in the camera, the process in the camera applies. This is curve we call as a non-linear curve. So how it is processed that? Like you see here, linear data that your camera records look like very dark and low in contrast as raw data that we can convert. That means that complete raw data which is right now keeping in the form of relationship in between linear and non-linear based on the applied operation, we may say a non-linear curve needs to be applied to it, make it look like a normal image that we expected to see. That means you simply can say understand that human sense, however, is not the linear. Human sense are not linear. So they are closer to logarithmic process. So this is your logarithmic, one of the operation. So that the eye expected to see something more closely, approximately a long curve, which is what non-linear means basically. So this is what we can understand a non-linear. That means non-linear you are going to be understand here. Non-linear means we can say that it is closely approximated a long curve which is what non-linear means basically. So let you can take one of the example. For example, you have taken the image. Obviously, this is the image. We may consider either 2D or 3D. So that means your image right now consider either 2D or 3D means your image contents of the data which are arranged in terms of m by n. M rows and n columns. So this complete data, that is here that number of rows and number of columns of the pixels of the data which contains a particular image which is right now we says that either in a 2D or 3D that we call as a maximum of maximum in between 0 to 255 pixels. So that means this is a normal data. This is a formal image process. Okay. So this data sets, this data, now we are going to be divided in terms of linear and non-linear. In terms of linear and non-linear. So how can you say as this number of pixels which help us in the form of intensity variation, then that variations of the pixels of the data may treated as or may be knowing the towards to human expectation, human visual expectation in the form of either low contrast or high contrast or what we call to say is that depends upon the contrast of the data we may divide either linear and non-linear. So we understand based on the previous slides of definition of the linear and non-linear, then we are going to be understand the content of the data which is from the image is right now we are defining either linear data. The content of the image is having linear data or non-linear data or non-linear data. So what do you mean to say here? You are going to be understand that which you are find out that complete the pixels of the information is right now needed in terms of applying certain filtering process. Why? We want to remove the noise. We want to convert the unwanted detailed data of image data is converted into known content of the data of an image. How we may convert? By using the linear filters. So what do you mean here towards applying linear filtering means linear filtering is the filtering method in which the value of output pixel is linear combinations of the neighboring input pixels. Neighboring input pixels. So that is the you are going to be understand. So that neighboring input pixels which help us towards to develop depends upon you are applying the your linear operation. Which is here linear operation? Now you have to capture the important point of today topic discussion, that is the linear operation which we are applying. That name of the linear operation we can call as convolution. Here it can be done with the help of convolution. So your linear filtering operation is convolution. So that means you are going to be apply such a linear operation is here we consider as a linear filtering, which operation happen in terms of convolution process. So what do you mean that? So with for example, you take your complete content of the data in terms of mean or average filters, or we may say Gaussian filtering. So this is what we can understand based on the linear operation. But whereas a non-linear filtering is one that cannot be done with a convolution. Why? Because we says that the convolution operation is completely linear filtering operation, which we simply says that it is a linear operation. It is a linear operation. It is a linear operation. So what we can understand is this is not a non-linear operation. That is what here it is. So with convolution we cannot do it cannot be applicable to the non-linear. Okay, or we may going to understand similarly from Fourier multiplications. Next, coming to the point, non-linear filterings have quite a different behavior compared to linear filters. Obviously, you have to catch that important point, that is based on the basic principle of linear and non-linear operations. We may say repeatedly as non-linear filtering operations have quite a different behavior. Behavior means which is perform the certain task of image processing, or compared to linear filters. So what we can say here is for non-linear filters, that filter output or response of the filter does not obey the principles of outlined earlier, particularly scaling principle process or shift to invariance principle process. Moreover, we can also understand that non-linear filter can produce results that vary in a inventive manner. Okay, inventive manner. So coming to here, how that inventive manner we may understand is here. I said here, you take one system. This is a image processing system. So here you are going to be apply your what we call your linear operations or non-linear operations. Non-linear operations. So what we say is that this is a system. This is a systematical process. What is that systematical process which we are concentrating right now is a image processing. Okay. So here we are giving the input data sets. What we are expecting is your output. So your output is here is we are going to be output of your, or we may say this output you are based on you are keeping some target data set which you are expecting based on applying either linear or non-linear operations. But you are going to be select here either linear or non-linear, completely you had to understand that this digital image processing, that is this image processing, you had to understand particularly depends upon the your knowledge. What is that knowledge? System knowledge. We say that system knowledge. This is knowledge. This is knowledge basis. We call as knowledge basis. I hope you got my point. So you are applying either linear operations or non-linear operations. You are going to be understand first of all image processing, which we wanted to process in between input and output relationship towards to achieve your required task. Nothing but your target of the data sets. So how you are going to achieve that? By applying either linear or non-linear. So that is very, very important, which we had to understand. That means a layman cannot come forward towards to apply either linear or non-linear operation to process the image processing. Why? Because it doesn't have knowledge about the image processing. But here, simple and basic principles of linear and or non-linear operations which you can apply depends upon knowledge basis of your image processing. That is very important here. Okay. So coming to the point, you are going to be concentrate here is if at all you are going to be shoot a JPEG images in the camera. What do you mean camera? It's a particular image processing sensor. It is a sensor. What do you mean sensor? It collects the certain input of the data. So once it's collected the data, then the data which we are going to be applying the process. That's what I have written here. The processor in the camera applies this nonlinear curve. So that means you stack the images of astronomical image processing program. You will normally working with the linear data when the stack is output saved. Then you would have to apply a nonlinear curve to it. So yourself during the image processing knowledge only. So knowledge, digital image processing knowledge will help us to understand the greater control over the data, how the data is we called as either in terms of linear stretched or non-linear stretched. If it is data is stretched to increase the brightness and or contrast of the faint stuff in a astronomical image that you have shoot. So that is very important is here. You are converting non-linear image into linear image. That means your required format you are converting. So coming to the here, the complete process which we had to understand, all raw file formats are linear. But when you open a raw file in a daytime image processing program like Canon's Digital Photo Professional or Photoshop, it will automatically apply nonlinear curve. So nonlinear curve in the sense which we are going to be discussing coming with the help of coming slides. Okay, let me see particularly what are the linear operations which we are concentrating here. Convolution process. What I mean here is you take the operator H as a linear operator. Okay, so for the any two images that we consider F one of the image, G is another image. In between these two images, we are applying your linear process with the help of two scalar parameter values which are named as A and B. You know the meaning of scalars, nothing but constant values. What is the use of these constant values? To make your complete process in terms of linear process. What do you mean linear? You are following this equation in the sense homogeneity will be there here. Superposition and homogeneity is there in this equation. That means linear principle or linear operation process is nothing but which obeys the superposition and homogeneity of the system principles. Okay, so that means you have to understand that the operator, any operator that does not satisfy the above equation or above condition is defined to be nonlinear. If not be satisfied this equation, we called as this equation we called as one of the operator. Okay, one of the operator. So when does not satisfy this equation, then we call automatically it become null. So that means you are supposed to be understand is here. So with the help of your complete the relationship in between linear and non-linear, which I says here h of AF plus BG. What do you mean this? What do you mean this? H of capital H of AF plus BG. So you may say applying the convolution process is here, that is A is the convolution, that is scalar value, H of your F plus B H of your G. What is F and G are the two images. So in between these two images, you are applying the linear operation. So when you are applying the linear operator is here in between two images with the help of your H operator, then you are proceeding that your achievement is here based on that means the complete condition. It is on condition. This condition is satisfied, then we call as linear operator satisfied, or else non-linear. Automatically become non-linear. Very simple to understand that. If you are processing your image processing with the help of linear operation, not achieved your required target of, or not achieved your particular concentrated task of operation, not achieved your particular task of operation, then it treated as that it can say that it is completely considered under the non-linear operation process. So coming to such a process which we are going to be understand in terms of fails, I can say I can use the word fails. That means you are using input and output relations where with the help of your linear operator which you are choosing H, okay, which you are choosing H, that linear operator should be in between, should be applied in between F, G and any two scalar values, then this equation will be satisfied. Okay, so then we are going to be use here such a process with, if it fails, that an operator that fails the test of the above equation, then automatically this equation, whenever it fails, whenever this test fails, what we call as test. What test? This operator, with the help of operator of the process in between two images. What are those images? We call as F and G. Okay, so F and G, two images which we are applying with the help of this convolution, that is this equation. We can say this condition not satisfied, it fails that condition, then automatically we can define that equation is become non-linear. That means simply we can say not equal. When is equal, it is linear. It is linear. When is not equal, then we can say it defined as a. That is what can understand is here. Okay. Right. So coming to the, let me to use some operations in between linear and non-linear under the categorizations of image operations. So far we concentrated on linear operation and as well as non-linear operation. But where we apply the categorizations of image operations. What are the image operations we says with the help of previous slide? We simply says H is one of the linear operator where we apply that linear operator in between F and G images with the help of two scalars, then we got this equation. Otherwise, it become a non-linear. Condition is not satisfied. Condition is not satisfied, then it says the non-linear. So try to understand here. We are concentrating the complete discussion only towards to understand how the image processing happen with the help of linear and the non-linear operations. That means simply we can say how these two are have the very good relation. If not satisfies this equation, then it is non-linear. If it satisfies, it's a linear process. So non-linear. So far we understood and concentrated linear operation which compared with the non-linear. Coming to the non-linear. What are the non-linear filters we are going to be used here? It is linearly filtered one. Another one non-linear can be divided into two groups. First of all, we have to understand this spatial non-linear operator that produces the output images array G of x comma y from the image which we are going to be use one of the image which is f of x y. Whenever you are going to be say it is f of x comma y, that means the image which is right now either 2D image which is having the values in the relationship of x-axis and y. Then you simply say the object of this 2D image function is f of x comma y. That means your task of the operations with the linear or non-linear will happen only by satisfying the another objective function f of x comma y, which is considered at the particular image. When you consider another image, there is another image. So this image we may say notationally with the help of other notations, that is g of x naught comma y naught. Because we say here x comma y. So this is another image, means the data of this image may 100% different from the f of x comma y of the image data, which varies in between coordinates of x comma y. So that's what. So same coordinates, right? So notations we can change. Instead of x comma y, here we called x naught comma y. So that we are going to be used here to obtain such a process in terms of non-linear function applied to the values that those pixels of the input images are f of x comma y within a neighborhood of the pixel x naught comma y. So we are going to be compare one to other neighborhood. So that means g of x comma y is your non-linear filter operation of tau. That is your function of capital F of x comma y, where capital F of x comma y is nothing but matrix neighbors of the pixel values x comma y. That is, we simply say these matrix values are these are the image. These are image data. This image data in terms of matrix. That means column wise and the other is the row wise. That is row wise. So that means once you understand the basic value of your nonlinear processing in between two of the image which you are consider for the operation based on the assumptions of one of the function f, another one is g. So here we take that operation is depends upon your tau value. What do you mean tau is? It is account position of the individual values in our particular f of x comma y, which is the function towards to concentrate on a nonlinear filtering process. Okay. So tau does not take into the account position of individual values in a f of x y. That is, the values matrix are considered as a set value, Okay. So coming to that set values, set values nothing but which we are going to be considered based on your non-linear operation. Non-linear operations. Okay. What do you mean non-linear operations? Yes, which are we are going to be keeping on towards to concentrating on f of x comma y of set of the values. These values in between x-axis and the y-axis of the coordinates values are varies in terms of pixels, in terms of columns, and rows. So this is right now we consider one of the object function of f of x comma y. These rows and columns values we are keeping in the matrix format. So matrix order, it is depends upon your object values of the function. So our matrix order is right now simply we can say a values of the image which are keeping in the rows and columns are maximum. These values are m by n. So that means simply we can say this linear and non-linear operations basically we can apply in terms of image processing method. Is it a H operation? That is H is a we can consider as a general operator. Okay, so your f of x comma y, h of f of x comma y, h of f of x comma y is operator here. Here your operator, then we will attain your nonlinear values. So that means your operation of h is concentrating here is linear operation, which going to be perform LHS equal to RHS. That is, you are expanding, expanding or you are transforming the complete values from f to g. How you are converting f to g in the sense? You have your transformation from f of x comma y to g of x comma y. So coming to here, the nonlinear filters are simply we can use in based on the behavior of your complete image contrast process. So that we simply can say nonlinear filters have quite different behavior compared to linear filters. For nonlinear filters, the filter output or response of the filter does not obey the principles outlined earlier, particularly scaling and shift invariance, because it is a nonlinear filter process. Moreover, a nonlinear filter can produce results that in a very non-intuitive manner. So coming to here, how these principles are various. Let us you say that the several principles define the linear system, which is we are completely had to understand from the earlier classes. So the first two are the basic definition of linearity. So you can understand that one is x of n equal to ax of n1 plus b of x of n2. The linear system response is here. You may be use x to y. What is x? X is input of your processing, your image processing. Y is your image processing system output. So we got it this. So this is known as superposition property. I told you right. The linear means obeys the superposition property. So that is fundamental to linear system design. Secondarily, we may concentrate on shift invariance. If you consider y of n is the response to a linear, that is the output of the linear image processing based on the shift invariant system with input x of n, then you may get y of n minus n naught is the response of the system with the input of the x of n. Excuse me. So what we had to understand here, you got output is this based on the input. So you see here, even at input you are varying with certain delay from n to n naught of the values, then the output also will be showing the same delayed content of the data. Okay, so we can understand that we take the system. I told you already. Anyhow, once again, let us repeat that very important process. So this is a system. This is a system. What system is? This is a digital image processing system. Okay. So you take the x of n here. You may get output is y of n. So for the maintaining of x of y of n is equal to x of n. We are going to be keep some scaling parameters here. Some applying is scalar parameter. Scalar parameters are here. So what are those scalar parameters are here is, you may consider if you are applying in between two images, you may choose two parameters. You may choose two parameters, a comma b. Okay, so based on that, your equation is satisfied here. Based on that, your equation is satisfied. Next, coming to the in case we want to extend the relationship in between in linear and non-linear operations is here, that we can say simply, in addition, two extra conditions are imposed: casual and stable. The casual condition is needed when considering the systems in which feature values are not known. For example, in video streaming, it is possible to consider a system that is not casual when looking at captured images with samples before and after the target locations. You say here target is nothing but your required data sets of the location, because you are using here image processing with the help of sensor based. What do you mean? What is the meaning of sensor? Your camera sensor. So that is your catched images may be affected in terms of, let me take some example, buffered version of an image frame. Stability is imposed to keep your filters output from exceeding the finite limit. So that means given input that also does not exceed the finite limit, because it is maintaining the stability. A linear operation is maintaining the stability. So what does it mean stable? What does it mean stability? Stability is nothing but, simply you can say, bounded input to bounded output condition. A linear operation, a image operation which obeys stable, which behaves stable, which having certain stability. That means it 100% satisfies one of the condition we called as a BIBO. What do you mean BIBO? Bounded input to bounded output conditions process. That means simply you can say your x value of x of n is equal to y of n. What are your n values are varies? That at input of the n values are varies, the output of the n values also varies. Same. That is bounded input to bounded output conditions. So you can take here with the help of one of the convolution theorem statement, which is you can use to understand linear operation, providing the necessary tools to evaluate the frequency domain information. So let us take one, two of the relations are here, that is two sequences. Their convolution is defined simply y of n is equal to summation k equal to minus infinity to plus infinity x of k h of n minus k. What is your x? Is the input. What is the h? It's the operator. Whom operator this? Linear image processing operator is h. Where it operator? In between x and y. Why it having the in between x and y? Because you are consider your image processing. Your image processing is here in between x and y. Is this y of n? It is x of n. So to maintain the values of output here, y of n divided by x of n, that means your h parameters. Okay, so that means this value should be unique, because why I keeping in the ratio is because BIBO is having stable, means it is always should maintain unit value as a 1. So that means your bounded input to bounded output condition will be satisfied based on your simple convolution equation with the help of two sequences. So coming to the here simple example, I wanted to take one example towards to explain on stability. stability. What I said stability means? Stability means what I said, stable. So simply it is nothing but BIBO. What is the BIBO? It is bounded input to bounded output of a particular system. So what is your system is here? What is your system? What is your system? Is image processing system. Image processing system. How you are concentrating here? Your image processing system operand is BIBO. Then what is your relationship of in between your x of n with y of n? It is always obeys the condition. What is the condition? Based on the relationship both towards to obey the condition BIBO, we may use the external what we call the condition satisfaction parameters we are using towards satisfies the superposition principle. Those are we called as scalar values a comma b, a comma b. Based on the a comma b, we may be prepare the equation with operand of capital H. So coming to the here, so when you consider your system in terms of frequency response system is we consider as one more equation is considered equation number 2. Previous equation is equation 1 where we are used BIBO equation. So what is your equation is here? Equation number 2 is simply we say depends upon your frequency variation is here. Your omega value variation. What is the omega? Omega value is always depends upon your in terms of x of the your input value varies in terms of n. Okay, so here we are going to be keep that frequency domain representation in between minus p to plus p. What is the p? Is one of the frequency response variable values. That is you can say n is equal to the values which are varied from 0 to p values, not in infinity. So that means fundamental relation describes your response of the filter in terms of frequency, either low pass, high pass, band pass, and so on. These all filters which are going to be considered as a linear filters for the operation of frequency domain image processing. So depending upon the nature of their filter, that is filter kernel values of h of n, a wide variety of responses can be realized for any image data set. So here we are using kernel process in terms of convolution process. Next, coming to a typical low pass filter. Now we extended your linear operation process in terms of frequency domain. Then you may say that your low pass filter with 25 tabs, that is your values are varies in between, that is n values. This is n values. These n values are varies. These n values are varies in between 0 to 25 varies. So the ideas of this discussion of this n values varies. Let us we can have one figure in coming slides. So with the help of that we can discuss in detail. Okay. So what we want to understand here is linear filter which we are using here, low pass filter. Okay. So that low pass filter, why we call low pass filter is that band frequency value is very limited value. Okay, low frequency information. That means low frequency and reduces eliminate the high frequency information in an image. So that means simply can concentrate on blurs the edges but keeps the smooth areas of an image intact. So similar manner, high pass filter preserve edges and other high frequency components, but filter low frequency ranges of an image. Let you go to your maintenance of low frequency elements and reduces the removes high frequency elements by the help of one of the figure which we are going to discuss right now. So from this slide, what we can understand? We can understand that the difference between linear filter, which is right now considered under the low pass filter frequency values, and a high pass filter frequency value. Low pass filter means the values which you are keeping in terms of limited. Otherwise, it reduces the high component of the frequency values. when we can consider high component frequency values, is here in terms of high pass filter, high pass filter we are going to be used. Okay, so see the filter is here, that relationship between linear filter and that relationship between low pass filter and high pass filter is here. The range of frequency values, the range of frequency values are keeping here. So the range of frequency filter responses in terms of dB. dB means decibel values. Okay. So because it is a frequency domain, so we are going to understand the decibel values. Why? We want to make the filtering process in terms of linear. So the values of linear always maintained in terms of frequency is gain, that is output by input. Should be gain value should be maintained unique. That is what that unique value in terms of decibel values. So that variations is here. So low pass filter values are your varies are linear. That is fixed. One band is fixed. So coming to the here, nonlinear filters which we are going to be extended in terms of understanding the linear filtering process. We linear filter process is here. What are the linear process filter we are using? Linear process filtering. We take one of the in terms of frequency domain. Frequency domain. So we are using one is low pass filter, low pass frequency values. Number 2, high pass filter. High pass filter. What is this differences here? So we have an equation is here. That is this one. So that is, what is this equation? We simply says that equation is y of a frequency component which varies in the omega values, that is x of e power of minus your omega into h of your e power of 0. So it's obeys. So this component of the frequency, this component of the frequency varies. Frequencies varies. Okay, frequencies varies. Right. So now coming to the here, that nonlinear filters we extended towards to understand the different behavior compared to the linear filters, or output or response of the filter does not obey the principles outlet of the earlier particular scaling or shift invariance, which is we can say that nonlinear. Moreover, nonlinear filter can produce the result that vary in terms of non-intuitive manner. So we can say that simplest nonlinear filters consider as to understand one of the name of the filter we call as median filter or rank order filter. You can extend it. So median filters or filter output depends on the ordering of the input values, usually ranked from the smallest to largest or vice versa, large to small also. So filter support ranges with an odd number of values is used, making it easy to select the. So we can understand some more examples are here. The region of interest based on the ROI, we can extend your values of the order from smallest to largest. The values position is we may keeping in second is selected as output. Consider that you are maintaining is low frequency, then the values are the same or closer to it because of it's a limited band. So in case of your values are selected or selected that our selection will be the original values in terms of plus or minus some small error, then in case that we extended with the help of high pass filtering process. That is High pass filter means high frequency values will be there, such as an edge values. One side of the edge will be low and the other side values will be the other side will be the high. So the values which are varying based on the you are taking your frequencies here and your values of the y of e power of minus j omega are varying. One range is here lower limit. After this range, after these variations are high range. So this is high range. So high range means it may be increased, the values will be increased from lower to high, or sometimes it may be keeping in terms higher range to lower frequency. It is fixed. So when high components of the frequency values are considered, that means high component values means higher range of the frequency values. Then we use the high pass filter. So when the ordering is done, the low values will still be in the low position, and the high values will still be in the high position. So you can understand that either vice versa. That is the range of values based on the keeping your operation process in terms of low position or high position. So a selection of the middle value will either be on the low side or the high. That is what we discussed with the help of previous graph. But not in the middle. So you would be the cause using a linear low pass filter. So that means your median filter is what I say, nonlinear filter. It is an example of nonlinear filter. What it concentrates, sometimes it says called an edge preserving filter due to this property, nonlinear property. So it is useful removing the outlets such as impulse noise. So coming to the, we are going to be keeping on our engineering process by selecting the right filter is here based on your linear data or non-linear data with the help of your knowledge in terms of real-time image processing. So it is not uncommon to have dozens of both types included to form or shape, detect or manipulate image informations. So moreover, each of these filter types can be parameterized to work one way under certain circumstances, another way under the different set of circumstances using adaptive filter rule calculations. So we can say you can use this to understand that right filter, right filtering process. Right filtering process. What is here right filtering is? You are going to use your image processing is here based on the image processing is here in terms of low order of the values in frequency and the high order of the values in frequency. That is W. Okay. So filtering image data is a standard process used in almost all image processing systems. That means the goals vary from noise removal to feature abstraction. Linear and nonlinear filters are the two most utilized forms of filter constructions. Knowing which type of filter to select depends on the goals which are in the nature of the image data. So we take that input data contains large amount of noise but magnitude is low. A linear low pass filter may sufficient. That is suffice. So we may conversely, if an image contains a low amount of noise but with relative high magnitude, then we consider it is processing a median filter may be more appropriate. In either case, filter processing changes the overall frequency content of the image because we are using here nonlinear filter. So, I'm going to close for today our discussion, which we understand in between linear and non-linear operations and extended with the help of filtering process, how the filtering process will be satisfied based on the superposition and linear superposition and homogeneity properties. So we are using here two equations. Equation 1 is for linear and equation number 2 is non-linear. That we define in terms of recursive domain. So here, such a domain knowledge, such a image processing domain knowledge in terms of applying the linear and non-linear operations towards to image processing applications. What are the applications we have to understand? We take a medical image processing. We take a quality control system process, surveillance, law enforcement, artistic effects. So mostly we can use either medical image processing or artistic effects. So we are using here the complete the content which I prepared in terms of PPTs from the textbooks. I used here is digital image processing, one of the textbooks written by Refil C. Ganjala. Another one is digital image processing by Jayaraman. Okay, so these two are very prescribed textbooks which are help us for understanding this linear and non-linear operations, many more detailed information. Okay, so with this conclusion, let me to close today's video lecture. I am very thankful for your patient listenings, for your any doubts or need clarifications. So we'll discuss in coming video lectures. Thank you so much. Thank you. I'm stopping here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.